In this video, let's see how to capture some distribution details and write a Linq query to find out how much a particular priest has spent until date. And in the process, I would want to explain a few important concepts there. So in order to save time, I've just gone ahead and created two buttons called Create Distribution and Show Distribution. In the Create Distribution, I do have a code to actually create a distribution and put some items in it. We'll come back to it in a while. And in Show Distribution as well, I have a query which will find out how much that particular priest has distributed. So let's go one by one. If you look into this Create Distribution, so the very first distribution in the database, the priest has decided that he will be using he'll be using laddu and rice as part of the distribution. Now, how many of it he'll be using depends on the devotees there. And just notice how I have this single. So the single actually returns exactly one item which matches the criteria. Now this has to be used carefully. If there are more than one items found with this name, it will throw an exception. If there are no items found in this name, it will also throw an exception. And that's a good thing because all your other code is based on the fact that you are able to find exactly one item of whatever you specified. And then that condition is no longer taken care by the developer. It's just the entity framework's way of saying no point in running any of the other code, so it's an exception. Of course, you can have some arrangements to try and handle it and do something differently, but either ways, the framework just wants you to be sure that if you said you expect a single item, it should get a single item. Any other case is a violation. So you might want to experiment around that when you can. Now let's see how the distribution item itself is created. If you see here, the distribution, I have just created a new distribution, and eventually I say context.distributions.add and save changes. If everything went well, we would say it's created, or we will show the error message accordingly. Now before we expand this distribution, I just want to remind you of how our schema looks. So if you see here, it will take a while to read the context and generate the schema. And here's the distribution detail. Yeah. A given distribution has several items in it because we'll have to capture what the item was, its unit price and quantity. Okay, so it's one distribution has many detail items in it. So with that in mind, let's come here and go back to here. So let me expand the distribution here. Yeah, there are a couple of observations here. First of all, we know that every distribution, a priest is in charge of it. And in this case, I just happened to retrieve the first priest in the record. So this is one way of possibly doing it. Or, if I really wanted to, I could do something like this. Priest ID equals 1. Now, provided we have a priest record with the ID 1, it would be associated automatically. So this is the advantage I was talking about initially when we designed the database and we created the entities, that always having the navigation property along with its ID or the foreign key ID is useful because you can then make the associations not with the objects, directly with the IDs itself. In web application development, several times you will have a request which comes back and it just sends an ID rather than in full object. No point in sending a full object right over the network when we already have the objects in the database and all we want is the ID of it. You could go ahead and do this. So you can use it in purely object oriented way by doing this way, or you want to have the best of both the worlds. Like if you are doing in database, you just deal with IDs, you could go ahead and do that as well. So this is the advantage of including the foreign keys explicitly. And also remember, if we do not include, there is always an inherently ID generated in the database, but it will not be available in the model since we have not included it. So we will not be able to make use of it, right? So let me take this off. And in the distribution details, so every distribution or one distribution has many distribution details. So that is why I have created a distribution details right under it. Now this is a syntax which you should be familiar by now. This is called the object initialization syntax. Rather than create the objects first and then set the properties, I can do it then and there. So if you see the commas separating here, and since this is a list, again, whenever I have a new definition coming up, I just give a line break. So that way it will be more readable. And since this is a list, if you see here, you can actually collapse all the details of the list. So that's the way you can actually imagine it. So basically distribution detail is a list of distribution detail, and there are two in this case because there were only 2 items distributed. If you could have had more, then there would be more such entries. We could just copy and paste this and create more entries also. You can try that as well. So if we look into a specific distribution detail, this is how it looks. Remember, in the diagram, what does the distribution detail have? The unit price, the quantity, and which prasadam it was. The distribution ID is anyway associated just because this object is a part of this distribution. Now this is another neat thing. You don't have to worry about giving the IDs. At least when you are containing this distribution detail within this distribution object. Creating an ID for this and then putting it here will all be taken care by the framework. So you just deal with the collection of objects as it is. Now even here, the same concept holds good. I could have done prasadam ID equals 1 if I knew that the laddu has the ID 1. Now since I do not know, I just went ahead and retrieved it and then associating it. So here we could associate the distribution detail with the ID or with the object, because we have the navigation property prasadam also included in our entity. So we would do it this way. And let's say we go ahead and distribute 100 quantity of laddu, and if you see this, I am also taking the unit price of this laddu. So you might be wondering, why did I take the unit price? Because this is already present there in the laddu item. So remember, we are maintaining a track of all the expenses which happened on that particular day. If you see here, date of distribution is on today. Now unit price, let's say it was 5, and if we make a copy of it in the unit price property, that's because maybe next day or some other time in the future, the unit price of laddu may change. So it doesn't mean this also should change. This is done, this distribution is done, and it was done in this price. So it is always essential that when you actually created an entry, you create a copy of what price it was, so that in the future we can always refer, or when we are about to write a query to get the price involved in it or the amount involved in it, we do not depend on the unit price. That could have changed by then. Okay, so we just make a note of it. And if you see the other distribution detail, it is similarly for rice this time. I have just called it rice, and the same thing holds good here, whatever we did. And we go ahead and add the distribution. The moment we add the distribution, naturally EF will detect that these are all related entries, and it will create the suitable entries for them in the database and take care of all the IDs and association. If everything went well on the context.save changes, we will get this, otherwise we will get the error message. Now before we actually run this, let us also take a look at how the show distribution is. There's a typo here, let me just correct it. Rename show distribution, click apply. And what we are doing here is basically for the first priest, we are trying to find out what is the amount he has spent, or he has made the temple spend for all the distribution he has done in all these days. So that's important, why I am stressing it here. So if you see, I am just getting the first priest, and I just want to get a hold of all his distributions first. So I'll say if at all I got the first priest. Now it would, what if we just run this on an empty database? My first or default would actually give me a null if there was no priest. So with this null check operator, I ensure if there is a priest object, only then this right hand side will be evaluated. Otherwise you get a null exception. So assuming that there was a priest and there is a distributions. Now you might ask me, why are we not checking for a null here? Because distributions might not have anything. Remember, every entity, whenever there was a collection, now in this case, if you see the distributions, priest, let's go back here, you see distributions. It is, since we are initializing a collection in the constructor, there is no way this distributions can be null unless you have not done this. And that is why, that is a good reason we do this. Even if you don't do, entity framework will not be affected, it will run fine. But in most of the queries where you do this, you have to keep on checking for its null. So as a convenience method, you just go ahead and instantiate a collection. What can happen though is this distribution can actually be empty, which is okay. We still don't get null exception. There is a difference between having a null exception versus something being empty. Now, let's assume we had a priest and we had no distributions at all. We had never had any distributions. So this distribution will be an empty list. So that is why this if condition will take care that only if there were any distribution, we will go ahead and do further processing. If we got an empty list, we will just skip that. Now assuming in the first priest we already have a distribution and we get this distribution at least with one or two distributions, and we enter this if loop. Here we will actually do something very important. If you see here, distributions dot select many. Remember, a priest has, or priest could have done several distributions, and each distribution has many details in it. If you carefully observe, since I want to now collect all of those, irrespective of what distribution they belong to. So this, I use the select many clause. It's a very powerful clause. Otherwise we had to again loop through this and find out all the distributions. So I just say distributions dot select many. So this is clearly understands the entity framework that he is interested in all the distribution details of all distributions the priest has ever done. Okay, that is why you have this select many. So now I have all the distribution details of that particular priest. Now again, if at all, if the details is there, I will say I have again put an aggregate operators here. I've said details dot sum of the unit price into quantity, a very powerful mechanism of using aggregation operators. Now I strongly suggest that you actually type this out and find out, because when you are typing, it will be clear as to what exactly what options you will be getting here while typing. That way you can understand the working of Linq also. But I intentionally came up with this query because this has a lot of useful information like selecting many, checking for nulls, and checking for if there are any entries. So there were quite a few things here. So the unit price and quantity we just multiply and take the sum of all those things, and we say the priest has made so and so distribution and it is amounting to so and so rupees. Otherwise, if nothing was here, we anyway have initialized the sum with 0, and since the distribution, let's say, just came out an empty list, not a null list, just an empty list. When you say a dot count, there will be no null exceptions because this is not null, this is just empty, and the count will be 0. So initially it might say the priest has made 0 distributions until today amounting to 0 rupees. But anyway, let's see all this in action in the next video.